Welcome to this edition of the Open Data Hub, of the Software Developer Thursday, sorry. The theme of today is the Open Data Hub MQTT broker we are implementing as proof of concept for the moment. Today the speaker is MArtin Rabanser here with me, who coordinated the implementation of the first proof of concept, which is monitoring the flight data of the flights over South Tyrol. I won't steal him much more time, and so the stage is yours, Martin. Thank you for coming.
Thank you very much, Stefano. Thank you for having me. All right, so you see, it's a very long title. We are going to talk about MQTT and flight data. So you might ask yourself, what have they both to do with each other? But let's see what this is about. Does it work?
Give the focus on the screen.
The focus on the screen?
No, on the laptop probably.
All right. So, well, just a few words. My name is MArtin Rabanser. I'm a business and technology consultant. I'm involved in many projects, and I'm doing basically, I'm working closely together with the Neue Tech Park on the Open Data Hub project, and that's very fun. Additionally, I'm doing some startup coaches, and I'm doing basically projects I like and innovation projects maybe. So this project here is one of them. And I have to give some credits to the team. I didn't do it alone, so we are a team of course, some guys, Christian Gapp, Alex Kompler, and Michael Überbacher. Christian and Alex, they are full stack developers. They're very, very good guys, so they really know what they're doing. Michael is constructing drones and it's in the drone sector, so he's very good on doing those stuff. And here are some links. Maybe they are useful then afterwards. We see it. So again, the story, why flight data? Why do we scan something like flight data? You see the planes above in the sky, so doesn't still work, so I have to click here. When you are up in the air, there's a lot of space. It might seem it's all empty, so you can do whatever you want, but it's not true. So you really have to be careful on the other planes and on other traffic. So the reality up in the sky looks like this. So it seems to be very free there, but actually it's very crowded. So you really want to know what's going on. Oh, thanks, Patrick. No.
Is it on?
It's on. Thanks. Never mind.
Go.
Okay. Where are we going? Anyways, so the sky's the limit, but the other planes are too. So you don't want to get near to them. And if you're going pretty fast, they are going pretty fast, so the ranges and the distances are pretty close. So the thing is, you have to know what's going on in the sky, and there is a technique to see the other planes. So that's exactly the same technique as flight radar. That's a screenshot, so the credentials to flight radar and other platforms, and that's ADSB. So that's not, for sure, not the only technique you can use. But ADSB has been created to see the others. So you have TCAS on the plane, and it's basically a surveillance technology based on GPS or Galileo, whatever. So the position the airplane has, it's kind of broadcasted to the ground, but also to the other planes in order that they can see where you are. And this is done. You are sending basically your identification, so your ICAO code, your velocity, your altitude, and the direction you are going, your position basically, but also the head. All of this is being broadcasted on 1090 megahertz. It's an open protocol, so it's kind of, you can read it in the air. There is no big thing on reading it. Thank you. Let's try if this works now. Yes, it works. Thanks. It's not encrypted, so a lot of things today are encrypted, but this is not. So you can read actually the traffic on there. And there are a couple of other techniques like FLAM used for the gliders, Pilot Aware, FANET for drones, OGN, Open Glider Network, and SkyMaster, and so on. And what we see here is kind of an example of the message. A message like ADSP, how this is in RAW. We will see it again afterwards, and you can build up basically your device to scan those data. And that's exactly the same thing as the ground stations get when they see you on the radar. That's the basic thing. Of course, they have then a more advanced technology as well. So what you want to do is kind of know where the others are. You see here. You see here that there is a device. Normally, there are devices in the big planes. There are devices you can see where the traffic is, but in the small planes there isn't, and they're pretty expensive. So you can have your own applications where they are, and with your own device, you see kind of what's going on there. You see the mountain here and the clouds there. So clouds are your enemy in the sky if you're not trained for instrumental flight. So therefore you really want to go you really don't want to go near to them or into them, but you have to know what's behind there. And you can see here, that's a screenshot that's exactly the same, let's say the same minute of the picture. So here you see the top of the mountain and the plane is here, and behind there is a helicopter, and that's 07 minus, that means 700 feet beneath this plane. So this is 700 feet, means about 200 meters, 150, 200 meters. And if you're going 200 kilometers per hour in the air, that's not really distant. So he's going into this direction, the plane is going to this direction, it's somewhere there. So he comes out behind the clouds, and you don't want to collide. So you really want to know what's going on there. Not to mention, of course, others like gliders that are maybe don't have a device or use a different technique. Either way, you're maybe asking yourself, okay, what does this have to do with MQTT, and why are we talking about planes and traffic with MQTT? But let's have a look. When you can create a device for the plane to see the traffic in the plane, you can build a device to see the traffic on the ground as well. So you can use basically the same device on the ground, and you can see the message, you can debug it, you can analyze it, and so on. And you can run it for days and, I mean, forever, 24/7. So you can collect this data. That's exactly the thing that Flight Radar, you all know probably Flight Radar, and they are doing basically the same thing. So what we did is basically building a ground station based on a Raspberry Pi with an ADSP receiver. So that's dump 1090. That's an open source tool. You can check it out on GitHub. And that's nothing we invented. It's already there. And that's a tool like TCP dump. You can just dump this data and read it or store it or whatever. And you have to have the right sensors, maybe a GPS position sensor to know where you are, and you want to have a great antenna or two to collect this data, and probably being outside to get those packages. On our tests, we did, or right now when we're here in Bolzano, we have between 0 and 20 messages per second. So that depends on the traffic we have above us. On a crowded day or on a crowded airfield, it can be more. Average, it's 700,000 messages per day, which is nearly 2 gigabytes on data, uncompressed, unoptimized, just reading the data how it is, getting it from the air. That's raw data, so SBS format, that's the recommended ECOW standard for the transponders you have in the airplane, because every airplane has to have this transponder. That's law that everyone has to have it enabled when he goes to fly, and he has to transmit his position, his altitude, and his velocity. There is no aggregation on the device, and we see that later. And basically, you can take this data and feed it with MQTT to somewhere, to database where the data gets stored. And MQTT is probably one of the techniques that fits the most for this case of scenario, and this is the connection to MQTT. So what we basically did is build a custom node application with the library, because MQTT library, the client, you can just include the library in your node application and send or publish this data you collect with the antennas to your database or to your system. And so that's something like, that's it's a screenshot or a piece of data, how it gets. That's maybe half a second or maybe less. And we see here, I mean, we don't have to go through it, but we see here message type, then we have an ID here, we have the timestamp, date, and the time. And here we have, that's the ICAO aircraft address. That's, for example, the Lufthansa flight 9456 from Munich to, it's cut to Venice. Anyways, I just Googled it, so nothing special here. And it's, here we see the speed in knots. It's more than 800 kilometers per hour, 443. The course, 180 degrees, so going southwards, of course, to Venice. And we see here descent rate, so he's descending. That's about 2,000 feet per minute. Yeah, could be. And that's the altitude, pressure altitude, for who knows the background on that. And we see here again, he is sending in another message, he's sending again his altitude and his coordinates. So we have four data packages to have one information. And this is streamed every second or even higher frequency. Each airplane is sending out these messages. In yellow, we see the Lufthansa flight, and in blue, we see that was a helicopter. Today, it's a GAF-W07. It's a military helicopter, and he was on about 8,000 feet, and he was below, and he was going to north. Here we see the degree where we see it, 46, so about 50 degrees northeast. And that's kind of an interception of the traffic itself. So what are we going to, what did we do? We, as said, we created this node application to send this data, to pack this data into MQTT packages, and to send it to a broker, so to an MQTT broker. And MQTT, why MQTT? Because this is extremely lightweight, and you can use it for a lot of scenarios, like your sensors, your little devices which have no just a battery or no big network connection, and this is pretty lightweight on using it. And the way MQTT works is kind of, the broker is kind of, I mean, if we take the example here, it's kind of, someone says, I'm the broker, someone says, here is beer, and I shout out to everyone that is registered, here is beer, so to other 5 guys. And if someone raises the hand and said, George wants beer, I shout out, George wants beer, to everyone. So every client can just subscribe and listen to the topic, and if it's not interesting for him, he throws away the message. Otherwise, he just interprets it and do whatever he wants with it. And you can send configurations for sensors, but you can also get, of course, the sensor data each second, each minute, each whatever interval you want to send. Okay, so having this, the messages are going to be lost afterwards if you don't configure it right, but you can configure your MQTT server in order to keep the messages, so when a client resubscribes, he gets all the messages. Of course, this is very memory consuming because your broker has to keep everything, and there are a couple of techniques where you can raise the quality of service, meaning you can say, okay, 0 is at most once, so the package is kind of sent. If the clients get them, it's good. If they don't get it, it's good as well. So once, that's kind of fire and forget. The quality of service 1 is at least once, so the broker tries to resend the message and make sure that each client subscribed gets this message at least once, but he cannot assure that he gets it 5 times, 10 times, 50 times, whatever, but he's sure that he gets it. So kind of the acknowledged delivery technique. And number 2, so 2 in this, the third one would be exactly 1, and that's kind of on a handshake. This broker makes sure that the client gets the message and he gets it once. So just once, if you maybe said, okay, raise your configuration by 1 or by 5, you don't want to get or to steal those messages multiple times because it's accumulating. And this is how such an MQTT message looks like. Here it's just a JSON. We packed it into a JSON, and this is one kind of packet we are sending on a regular. We are streaming in the same amount as the planes are sending us the data. All right, so having this, there is, you want to do more. So you don't want to stop there and say, okay, I have this kind of, I read the data from the air, I have a broker, and the broker is there. You maybe want to connect the database or something you can process the data afterwards and so on. And this is where the components come in, components that help you to process the data. And we extended the project in a way that we can get this data into the Open Data Hub. And we need, of course, something like, okay, that's the station. Then we have a broker. We use Mosquitto. We see it afterwards. We need something with pipelines or something where we can forward the data and process the data, send it to a database, or modify it, transform it, aggregate it, or whatever. So that's the integrator part. And have interfaces as well. And here we have a database like Postgres or whatever, where we can persist this data. And in the end, we have a web component to show all this. That's kind of the outcome there. We will see this slide, so don't worry. So starting by the broker, we choose Mosquitto. Why Mosquitto? Because it's well known, it's open source, it's from the Eclipse Foundation, maintained by the Eclipse Foundation. It's well supported, so we just took Mosquitto. He has an authentication as well, otherwise everybody could just subscribe and write whatever he wants in your topics, so an authentication is always good. And in our scenario, he has no data persistence. So if he goes down, data is lost, this data is not forward. And this is something you could solve, and if a client is not connected right now, he doesn't get the data. This persistence, it's something you can configure, and that's, of course, to decide upon your project if you want to use it. The integrator part is the next part. This is, of course, this pipeline, the Apache Camel. So we tried to process the data in the Apache Camel. It's a kind of high-level tool where you can just say, okay, I want to stream the data, take the data from the Mosquitto, put it into the database, put it onto a REST API, and enable as well a WebSocket interface so that you can just share the data wherever you want. And we kind of did that and stored the data one-to-one in a generic database. And these packages you see you saw before that the planes are sending 5 messages to get one information. So we just kind of aggregated that and stored it as one record in the database, and we activated an API so someone can say, okay, in this hour, yesterday, on this position, give me all the planes you had there. So this is the records, then you have the single records and not various messages you have to aggregate. And WebSocket, we activated the WebSocket interface as well, because REST doesn't really scale for such applications, because you have, when you get this data onto a web component, we see it afterwards, and you have a website with 1,000 visitors, so you have 1,000 REST calls on your API in this second, and that's probably with the polling, because the planes have to move, like in Flight Radar, they have to move in a map, and you have all these REST queries you don't really want. So WebSocket is the better technique here and scales better. Web server Nginx is somewhere in there to solve a certificate thing, because it's encrypted, the internal communication. So, but that's nothing of matter today. That's kind of a graph how the Apache Camel works inside. So from the data collector, the device scanning in the air, he sends the data to the message broker with the node script. The message broker Mosquitto has these topics. He gets the data and he holds the data and shares it with the Apache Camel. Apache Camel takes it. There are in-stream in-memory streams, and you can just divide here. This in-memory stream divides the raw data to WebSocket and stores it as generic data. Here is forwards it to another in-memory stream where he does the aggregation in here and stores it, puts it out in the WebSocket and stores it as well. So this is just kind of what you can do with this pipeline concept. And we didn't, but this line here would show that you could give back to the Mosquitto the aggregated data if you want so. So someone can subscribe and take from Mosquitto the aggregated data. All right, let's have a quick look to the database. The database, as said, stores the raw data, stores the aggregated data, and it's in a week. It's about 7 million records, so it's pretty a lot of data. And but data you can optimize, of course, because there is no need to have for each plane one message and one GPS point per second, because planes in general go pretty straight, so they are not doing angles in the air. So kind of you can store it as a vector, because with 700 kilometers per hour or 800 or more, it's kind of clear that if he changes his course, you can describe it with a vector and just accumulate data and store much less data by not losing anything. One additional thing we did, and that's something because it's interesting for afterwards, we tried to insert the SkyApps flight schedule as well. So SkyApps is the local air company here, and we wanted to have this data as well to see when they detach, when they come back, and but we have to know when they are going. So kind of this scheduled flight, we had to know it. We asked them. They sent an Excel file, so we had to insert that manually just to have the data. But we are working on having this on a REST API and getting this data on a regular base. That's kind of another data flow, how the data flows here. It's kind of the same concept where you see the green one is the flow of the real-time data, and the blue one is the static data, but also through the Camel, through the Mosquitto, and ending then in the Postgres. Let's come to the output. What's the result of all of this? The result is a web component. We decided to do a web component because it can be used by many others. It's free on the repository of the Neue Tech Park, and the source code is there as well. And there is, in a minute we're going to see it. And that's a screenshot where we basically integrated all this information in one visualization. So we have a map, we have then kind of this classic from the airports, departures, arrivals, where the static data is, and here we have the real-time data, and the map would show a similar thing to flight radar, radar box, or the other tools, All right, so let's see let's see some lessons learned here, and then we can go to the web component and check it out. The lessons learned would be the data quality. Sometimes we saw in this proof of concept, in this work, we saw that sometimes the live air traffic packages are wrong. So if they are far away and if they are behind a mountain, some bits can be different. And we have currently no checksum if the data package is correct. And if you have 1 or 2 bits different, that makes a lot of difference on your coordinates. So the airplane might be in another place. And on your map, it's kind of, he's going there, and then he's there. So, and then he disappears. So this is something we have to check out. And you see then the map, but you have to analyze the data. And given from the technique, the ADSP is not perfect, so even ADSP has issues on being non-precise, non being compatible with the cockpit setup they have and whatever. So you have to really dig in pretty deep into this technique to understand every problem they have. And as said before, the amount of data could be reduced by storing vectors, aggregating and storing vectors instead of the plain data. All right, so let's go back here and let's have a look at the component. And here we are. Here we are. Full screen should be here. All right. It can be. Okay, so we see basically the map here. We see the static data on departures, arrivals, and we see the live traffic here. And that's, I don't know what SWR would be. It's a large one, so that's the class of the aircraft, like the heavy, the large, and the super. Super is Airbus 380, and yeah, we see here the altitude is 39,000 feet on a speed of 430 knots, and the track is 280. Yeah. Great. All right, that's my presentation, and feedback is welcome and questions as well. Thank you.
Thank you.
Thank you, Martin, for your nice presentation, interesting presentation. So now it's your turn. You can post questions. I remember to all of you that if you want, you can find some drinks there behind, so feel free to take it. But first of all, make a question, post comments.
One question about back. Okay, I can speak up. Okay, with a microphone. Question about the vectorizing. Can you elaborate on that process? Because I mean, this is something that is that an algorithm, or how do you deal with that?
Microphone is needed for
Exactly.
people online.
Well, basically, you have to take the coordinates, draw it in the 3D room, in your virtual room, and see from where to where the plane was going.
Yeah.
And on each change of angle, speed or something, you have to store another data point.
Yeah.
That's kind of you
Exactly.
do it.
And you have a kind of an algorithm that does it automatically. All that.
No, the thing is, that's theoretical because we didn't do it.
Okay.
Right now we are storing the plain data, but it's vectorizing the data. That would be the way to go to minimize the data. We didn't implement it.
Okay.
That's kind of the thing you would do.
Okay. Once you do that, let me know.
Yeah.
Okay.
We will do. Okay.
Yeah, I think I can speak up. That should be fine. It's very loud.
For the streaming.
For the YouTubers. So I was wondering, this protocol that is broadcasted by the airplanes, does it have a checksum? Is there in the protocol a checksum you could use to find these flipped bits? Oh, there is. Okay, great. Yeah, so that should be easy to discard them wrong. The second question is, did you, I understand this MQTT thing is between your box and another box at Node that stores the data finally in the Open Data Hub. Did you consider 0MQ there also, besides MQTT? 0MQ would be the even lighter weighted small cousin of MQTT.
Thank you. Thank you for the question, Chris. There is, the box has this custom script or custom application sending the data via MQTT to the broker. The broker is in a Docker, in a virtual machine in the tech park, my tech park on the infrastructure. And there's the broker getting the data, and the integrator is another Docker, another machine that takes the data or subscribes to the broker, takes the data and processes the data. We looked at the different brokers and we choose Mosquitto. We didn't then do an analysis of which one would be the best in case of, so we tried to take Mosquitto because it's very well known, and we wanted to try it out to know how if it is performant enough, because basically you can set up more boxes, getting more traffic, and then you have much more data, and so you can do a performance test pretty easily. So that was the idea behind choosing Mosquitto, because probably Mosquitto should then be configured in the right way. But of course you can use other queues or other MQTT systems as well.
So basically you pick Mosquitto, and Mosquitto speaks MQTT, so you said, okay, I'm happy with that, because Mosquitto is the one I want.
Exactly, yeah. But we could do a comparison, so it wouldn't be any problem to set up another MQTT system, redirect the traffic in both places, because the Raspberry is fast enough to send it. And if you have more boxes, of course, you have more traffic. And then you can compare the two techniques, because the Camel behind it could take it out and measure it even. So you have a perfect comparison.
Can I, as an Open Data Hub consumer, connect to the MQTT broker directly?
Well, the answer is, the short answer is yes, but you can connect. If you have the credentials, you can connect and you can consume the data directly there. But that's not intended, because then you're kind of bypassing the Open Data Hub and having raw data directly in the queue as the data hub gets the data. So maybe you're someone that wants the raw data, and that's a scenario that could be interesting for some kind of project or whatever. But the idea is to get the raw data, to store the raw data, to put the raw data in a transformator process, then have a data mart, and the Open Data Hub shares the data afterwards with you as a customer or a consumer, because mostly on each scenario there has to be done some transformation. In this case, the Open Data Hub, or let's say the infrastructure and the environment of the Open Data Hub, would do the aggregation of the data, which you wouldn't do. So basically you could subscribe there, but let's imagine we have 50 boxes. You would have to subscribe to 50 of those topics and aggregate and do basically the same work as the Open Data Hub does for yourself. And that's kind of not the right way, because then you can't get data packages from airplanes twice, because if it's overflying 2 boxes, you have the message, duplicate of the message, and that's the work that the Open Data Hub would do. So kind of it's, yes, but it's not intended, because there is something behind it.
If I am interested only on the real-time data, so the whole table storage and
right,
such doesn't matter that much.
Right, but if we go back to the web component is getting the data by WebSocket, but it's not getting the plain data like the single messages, because otherwise the web component would need to aggregate the data, and that's not the case. The Open Data Hub infrastructure is aggregating the data and sending out the real-time data via WebSockets, so the web component or you as a consumer get the aggregated data with a real-time interface that's shared by the Open Data Hub. So the web component takes the data and shows the plane, and that's it.
Maybe I can add something, because as I said at the beginning, this is our first step as Open Data Hub to go into pub/sub architecture. We decided to start testing it in the inbound architecture, but in case of need, in case we have requests from our clients, let's say, we can also consider to expose data with an architecture, MQTT or pub/sub, where you can get a stream of data, of different kind of data. We do not have only the flight data, we have also traffic data or other sensor data that we can share with such a kind of architecture. What Martin is trying to say is we cannot expose always the raw data, because we need to aggregate it. We do a little work to simplify your life. So if we receive requests from our clients to have a MQTT broker also exposing the data, we for sure foresee to update our architecture to do that. At the moment, I do not have deadlines, but we are starting this work, and I think that this year would be a preparatory year, and by the second half of the year, we will have the idea more clear about that. Any other question?
So what's the cost of building a DIY box for collecting the data from the transponders?
Yeah, that's a good question. Let's say it depends on your components, how good they are, and how far you want to see or receive the real data. I read on some pages that you can do such a device with, let's say, 30 euros, so below 50 bucks. Then you have kind of a homemade antenna with some TV USB stick, so you can use it. I didn't test it. I mean, it should work. I read that it works, and Flight Radar, Radar Box, and the others, they are even sending you their interfaces, or you can buy them, and they cost about 100, maybe a bit less. But they need, they want you to feed their platform. So They are happy if you get this device and you get a free account, but they are getting the data, of course, as the big ones. And they are aggregating this, and so the more devices they have around the world, the more information they have, and they cooperate with the airports, they cooperate with the airlines, so they have really, that's really their business. And their premium account costs about 400 euros per year, so it's kind of interesting whoever wants to build up his own device, feeding them, gets this professional or this advanced account. The device we did, to be honest, I didn't sum it up, but some 100 euros.
And what's the range of capture? How far does it?
Line of sight.
Ah, okay.
Yeah.
So behind a mountain is.
Not really. Yeah. I mean, you can get something like the helicopter. You get it if you're there and if it's just behind the angle. But the further away they are, the less quality of packages you get, and then you get half packages, you get some types of messages, you don't get the identification anymore, you just get the altitude, not the coordinates, so kind of it lacks the quality there.
I have now a very technical question. Don't laugh at me. Maybe you have heard about this Twitter guy who is tracking like Elon Musk and other celebrities. Is he using this kind of technology? Do you think he's tracking them with this specific radio signals?
Yeah, the same guy came to my mind during the presentation. He is doing basically this same thing and the same technology, but he's not having the devices. Because if he had devices around the world to track Elon Musk, so that would be a bigger problem for Elon Musk as well. He's basically getting the data somewhere, like a professional account, because there are other, where it is, there are others like Flight Radar, Radar Box, Flight Aware, OpenSky, ADSP Hub, and so on. But almost everyone asks you to sign an agreement that you're not going to share the data. So he must have found someone where he can do that, or he pays for it, or whatever, and then he does it. Basically, he does it, and he doesn't say anyone how he does it or where he gets the data. But the data is public. If you are in the plane, you enable your transponder, and you have to, because when you're airborne, you have to. Otherwise, you're getting into trouble. Trouble meaning they shut down your license and stuff. So basically you have to enable it, and your code is your code. It's kind of the MAC address of a network card, and it's like that. So you're kind of public, and if someone knows that's your plane, he can track you, and that's kind of a problem. And the authorities know about it, and there is some prevention where you can say, okay, I will set a temporary address for this flight, so you're kind of security by obscurity, kind of you're hiding what you're doing, but in the end you're always public, except military.
I think if you switch this off, you will see 2 fighter jets next to you.
It depends in which airspace you are. So if you're on the mountains, probably not, because they are not, that's Gulf, so airspace Gulf, they don't care. If they're doing that over Istrana, Aviano, yeah, you have new threats. Yeah. The thing you can do then is lower your speed, because when you're getting lower, the jet fighter gets into trouble because he can hold up with his but that's not solving a problem.
I do have a question as well about the amount of data you collect in one day. Do you have statistics? Because I think that now the traffic is becoming again much higher, and so
No, we didn't do any new statistics. We have to redo statistics and compare it. We implemented one script or one scheduled thing that moves the data from the database to cold storage to be processed afterwards. Otherwise, you're getting hundreds of gigabytes in the database for probably something that can be optimized.
Are you using this data afterwards, apart from the real-time tracking?
If we are using the data afterwards, we are trying to collect the data, to store it, and to publish it then. Yeah, why not? So this can be a matter of some master project or some analysis of how much air traffic is passing by over the region. Of course, to have a more, I wouldn't say global picture or a wider picture, you need more boxes around the territory to analyze how much data is there. Yeah.
Do you plan to store temporal data?
Temporal?
Yeah. It's from a timeline of data.
I repeat the question so
Yeah.
you hear the microphone. If we plan to store the data in a temporal way, yes. Actually, the REST API, we enabled the REST API, and it's one slide I deleted today. But I had one slide where there are the parameters for the REST API, and there you can set the date and the timestamp and the airplane or whatever. So what you can do with that is you have the real-time traffic on your web component, see moving, and down you have a slider where you can go back in time, and the REST API is just, you're doing calls on the REST API to say, okay, give me the status from yesterday, 11 o'clock, and it shows you the picture then, and you can go back and forward in time. We didn't do it in the web component because we hadn't time to do it, but the REST API is prepared, and it's an invitation to fork the component and implement it.
someone else has questions? Otherwise, I will do, as usual, a short presentation round, and then we can start the networking one to each other and discuss and enjoy the drinks. So I start from here.
Hello everybody, my name is Daniel and I work for EcoSteer.
My name is Simon Alva and I'm working here at the Neue Tech Park as software architect with Stefano, Patrick and other people.
Hi, my name is Ilaria and I'm studying business informatics in Bolzano.
Hi, my name is Tobias and I'm a freelancer.
Hi everybody, I'm Patrick. I work for Neue Tech Park.
Hi, I'm Patrick. I'm a web developer. The topic was interesting for me, so I'm here today.
Hi, I'm Chris Meyer. I'm also a freelance programmer and consultant.
Hi, I'm Stefano. I'm a web developer and a freelancer.
Hi, I'm Gabriele. I'm a software developer for Group of Us.
Hi, I'm Georgiana and I'm software developer for EcoSteer.
Hi everyone, I'm also Gabriele and I also work as a software developer at EcoSteer.
Hi, I'm Aaron. I'm working on UX research, data engineer.
My name is Christoph. I'm running an incubator in just across the border in Switzerland. We focus on space technology.
So, I'm Stefano. Everyone of you probably know me. I work at Noetech Park. And thank you, Martin, for the nice presentation, the nice introduction to MQTT and to the presentation of what we did also together. Thank you for coming here. Thank you all to all online participants. I just remember that the next time we will do a presentation about data mining in IoT sector. So it's not that far away from the presentation of today. And we won't be here at the Noise, but we will do the next event at the Makerspace. That's just there, but you will receive the communication with the exact position in the Noetech Park where the event will be. And then I remind you that on Monday we'll go online the program of the Open Data Update that will take place the 20th of May. So go on the website, see the program, and make a subscription to the event if you are interested to participate. So I hope to see you to the next Software Developer Thursday. Enjoy the evening and have a nice day.